In this presentation we look into more details about SOH TOA, which is necessary for determining mathematically the values for vector addition. So CAH TOA is short for a trigonometric function in solving relations of angles and its lengths for right triangles. We can recall that the definition of a right triangle is having one of its angles equal to 90 degrees as shown by the figures here. So we see that a triangle may be oriented in various positions as long as one of the angles is equal to 90 degrees is considered as a right triangle. The longest length in a right triangle is called the hypotenuse, and we see that it can easily be obtained by examining the triangles as shown here. Consider an arbitrary angle beta shown in these positions and we identify the lengths called opposite and adjacent. The figures shown here are the opposite lengths, which are simply the length that the angle beta is facing. The left figure where beta is facing the vertical length of the right triangle. The figure on the right, it is the line that is in opposite. The position or length called opposite is dependent on which angle we are referring to. We see that in the second figure where we define the angle alpha, the length opposite is positioned at the bottom. So with respect to beta, the length opposite is the vertical line as shown on the figure on the left. For the alpha angle, the length opposite is positioned at the bottom, which is the horizontal line. The length called adjacent is positioned right next to the angle of interest, which is not the hypotenuse. So we examine the figure here that for the left figure it is positioned at the bottom, which is the horizontal line, which is right next to the angle beta. For the figure on the right, it is the inclined length that is right next to the angle beta. The position called adjacent is also dependent on which angle we are referring to as shown below when we consider an angle alpha. Here the length adjacent is defined differently. For the angle beta it is the horizontal line right next to the angle beta, and for the angle alpha it is the vertical line. Let us apply the concept of SOH TOA. SO is short for the trigonometric function as shown in equation 1. We see that the letter S stands for the sine function, and here it is sine of the angle beta, and it is equal to the ratio of the lengths opposite and the hypotenuse. So, sine beta is equal to the opposite length over the length of the hypotenuse. Here we have an example where we let the opposite equal 1 and hypotenuse equal 2. We are then to find the angle beta using the SO trigonometric function equation 1. We apply and do some inverse sine function of the values substituted. We get beta equal to 30 degrees in degree mode, or about 0.523 radians in radian mode. Now let us consider the second term CAH, and this is short for the trigonometric function as shown in equation 2 as shown here. Cosine function of beta is equal to the ratio of the adjacent length over the hypotenuse length. Let the adjacent equal square root of 3, which we obtained using the Pythagorean theorem. We substitute the values of the hypotenuse adjacent to equation 2 and we get that the beta angle is equal to 30 degrees or about 0.523 radians. Now let us consider the last term TOA, and this is short for the trigonometric function as shown in equation 3 as shown here. Tangent function of beta is equal to the ratio of the opposite length over the adjacent length. Now we use the tangent function to obtain the value of beta using the lengths of opposite and adjacent. Substituting the values of the lengths to equation 3, we have here the value of beta, which is again equal to 30 degrees or 0.523 radians. So we are to write the proper expression for different angles using SOH TOA. Here we have a vector A with its unit vectors I and x as shown in the figure. We note that the relationship of the vector A to its components is given by the Pythagorean theorem as shown here in equation 4. The vector A and its components can be redrawn forming a right triangle as shown in the figure, and hence we are able to apply Pythagorean theorem. So vector A is the hypotenuse and the components are its opposite and adjacent with respect to the angle theta. So we can now write the different trigonometric functions with respect to the angle theta. For the sine function, it is obtained using equation 1, and we get equation 5, which is the ratio of the vector component y of A over the vector A. For the cosine function, we use equation 2 and get equation 6, which shows that the cosine function of theta is equal to the vector component x of A over the vector A. And finally for the tangent function, which we use equation 3 and get equation 7. It shows that the tangent function of theta is the ratio of the components of A, which is vector A of y over A of x. Note that we use the scalar values or magnitude only for all the vectors A and its components, since we are currently interested on how the trigonometric functions should be utilized depending on the angle of interest. So we determine the trigonometric function for the angle beta where it is positioned on the fourth quadrant. So we see that the y component is oriented downwards, and this should give a negative value of its direction, but for this case we are only interested in how to write the trigonometric function for such a case, thus we only utilize the scalar values or magnitudes only. So to write the trigonometric function we use equations 1 to 3. For the sine function we have equation 8, where the opposite length is given by the b of x component. For the cosine function we use equation 2 and we get equation 8, where the adjacent length is the b of y component. For the tangent function we use equation 3 and we get equation 10, which is the ratio of the components b of x over b of y. The end for now. For questions and comments you may send them to diyeslearningstuff@gmail.com. You may review the slide on YouTube at @dies_learningstuff. Note, please do not forget to use your school email. Also write your complete name and class section. Thank you for listening and see you next module. The end for now.